Tesla We Robot event was one of the most cinematic technological presentations I've ever seen. Of course, lacking technical details, unfortunately, but I can infer a lot from what I've seen. And who doesn't like a great technological show? I even sacrificed my sleep today to watch it. As a hardware engineer with almost a decade experience in automotive industry, in today's video I will be focusing on the engineering perspective, on the engineering aspects of these innovations, how Tesla is now entering a huge positive feedback loop, and how these innovations will disrupt automotive and robotics industries. The main announcement at the event was the Cyber Cab.
Wild experience to just be in a car with no steering wheel, no pedals, no controls. So I hope this goes well.
The robotaxi market is expected to explode in the next years. This is a huge opportunity for Tesla, and this will change the economy of transportation. First of all, it will bring down the cost per mile, from now roughly being $1 to 40 cents, all the way down to 5 cents with the RoboVan. And this has a huge impact on the entire automotive industry. This will change the way the cars are designed, sold, and serviced. The thing is, today's car is built for an average use of a couple of hours per day, which is about 10 hours a week. And with that, it serves on average 12 years. Robotaxis will operate nearly non-stop, about 100 hours a week. This means the car will be used at least 10 times more. This extensive use will put a lot of pressure on the electronic system, on the chips in the car. And here we are not talking just about the hardware but the rest of the chips, like hundreds of chips in the car that are used to control safety features, advanced assistance, infotainment, all of them will wear out much faster. And you don't want to replace your car every year, right? Well, in fact, in the modern cars, 45% of the costs is accounted for electronics. That's because cars are full of chips, and also these automotive chips are very expensive. They're expensive because they are engineered to be very safe, to withstand very different conditions like temperature variation from very cold to very hot, high humidity levels, vibrations, and so on. And nowadays, all these chips are designed with a 10 hours a week mission profile. In the robotaxi world, this will accelerate. This means we have to build all these electronics, all these chips to be 10 times more robust. And this is a big deal for the industry. We are actually talking about this transformation for the last decade, so the industry is prepared. You know, there are many design techniques can be used here. First of all, you can implement redundancy. We can also apply dynamic frequency and voltage scaling so that high voltage is applied only when it's needed, so the chips and the electronics wearing out slower. Eventually, chips will become more complex, and this will result in higher R&D costs and testing costs, and this will apply to other car components as well. Now, Cybercabs will be delivered by the end of 2026, featuring the hardware 4 chip. But now Tesla is already working on building something more powerful, AI5 chip. It will be capable of 10 times more computing and, of course, more latency and more throughput. For now, this computing power is actually much more than they need in the cars, but algorithms are keep evolving, and this chip have to serve them for the next 5 years at least, so they are intentionally over-engineering it a bit for the future. What's interesting, Elon mentioned that when the car is not used, the hardware can be used to build a distributed computing system. Now, let's reason a bit about these numbers. They estimate 100 million robotaxis on the road. Each of the car features a 1 kilowatt of power chip, which is of course then has to be recalculated down to the computing power. This results in 100 gigawatt of distributed inference power, and this is quite a number. The biggest question, is it usable? Probably yes for their case, but you would need a really high communication speed. And, when we're talking about data centers, this is hundreds of gigabytes per second. And you can't expect this with a home Wi-Fi, right? So this all is a bit of a stretch. In general, Tesla is scaling up their computing to terawatt range. They are scaling up their data centers to prepare to do much more computing than today. As I mentioned, I compromised my sleep a bit today to bring this video on time to you, so my mind is a bit unclear. But if you're enjoying it, please support me with a like, consider subscribing to the channel, and if you're enjoying it, share this video on your social media. This means the world to me. Thank you. What's interesting? By deploying robotaxis, Tesla is entering a powerful positive feedback loop. Because the number of miles driven will increase at least by a factor of 10. This will allow Tesla to collect a lot of real-world data, and this will be their mode. The positive feedback in engineering defined mathematically as a positive loop gain around the cause and effect. When the loop gain is above 1, there will be typically an exponential growth, which means basically the more you do, the more you become. The more cars you've deployed, the more data you can collect. And this will be crucial not just for autonomous driving, but also for the training of humanoid robots. Companies like Boston Dynamics have great robots. NVIDIA is working on Groot project. And for both of these projects, the biggest challenge is collecting data for the training. And Tesla has a huge advantage here. Talking of robots, during the We Robot event, robots were walking among people, and I think it's gonna take time until we get used to that. But these are designed to revolutionize households and factories. Goldman Sachs projects that the humanoid robot market will reach $38 billion by 2035. And I read the full report, and the key takeaway is that the biggest part of these robots will be high-spec robots, like those from Tesla and Figure AI. Their estimation that 6.5 million robots will be sold in 2035. In my opinion, it's a bit optimistic forecast, considering that the closest thing to the robots we have now are cars, and there are about 15 million cars sold a year. So this projection is a bit optimistic. However, Tesla announced that already by the end of the year, thousands of humanoid robots will be working in the fab. What's interesting, back in the 1970s, 20 million Americans were employed in manufacturing, over 20% of the total workforce. Today, that number has halved to about 10 million, and humanoid robots will disrupt it even further. What differentiates Tesla from other robotic companies is their efforts in autonomous driving software and, of course, custom silicon. Any navigation in the real world requires lots of processing power at edge to process vast amount of real-world data. They will enable this processing with the Hardware 4 and AI 5 chips, which will be both coming to robots and cars. That works for now, but in my opinion, when they reach a decent volume with humanoid robot sales, they could optimize this chip for the humanoid robot specifically to get to the smaller area, smaller cost, smaller power consumption, because obviously car and robot have different power budgets, and they can cut down some costs with that. Actually, we can conclude a lot from this event. First of all the investments Tesla were making over the years in their autonomous driving software, robotics, and especially in custom silicon like Dojo, like the Hardware 3, Hardware 4, it's all eventually coming up in a single picture, and it's all paying off. And I'm certain that great companies have to reinvent themselves. I love that Tesla is coming up with new revenue streams. Otherwise, you end up like Nokia, who missed smartphone, or like Intel, who missed the mobile chip market when Apple came to them. This happened many times to great companies. But I also love seeing autonomous driving coming to life. I'm really fascinated by this, because now we don't have to take care of cars. Cars can take care of themselves. When you buy a car or rent a car, it can just drive itself to you. When I was in San Francisco, I saw lots of Waymo driverless cars outside. And they're different from a typical car aesthetics because there are lots of lidars and sensors, and it just looks bizarre. Tesla does way better job here. This looks like the future. Let me know what you think in the comments. And I'm pretty sure over the next decade, we will see robots everywhere. In service, in hotels and restaurants, of course, in the fabs. Sorry for the sound. And this will be, of course, enabled by sensors, by improvements in sensors, silicon, and AI. Let me know your thoughts on this event in the comments. Unfortunately, there will be no updates on Dojo in this video, but make sure to subscribe to the channel not to miss the future episodes. And as a present for you to celebrate 200 subscribers on the channel, I wrote a paper on the semiconductor industry, which is summarizing the entire semiconductor value chain on 7 pages. I'm really proud of this paper. It's a really beautiful one. Make sure to get your free copy through the link below. Thank you for watching. Thank you for your support. I will see you in the next video. Ciao.